The broadcast is now starting. All attendees are in listen-only mode.
Good morning, folks. We're going to get going in just a few minutes. I say good morning. It's 11 a.m. here, local time in Cleveland. I know we've got folks from all over the place joining us today. We got a nice crowd anticipated, and we're looking forward to get going. We're going to get started here in about 4 minutes or so. Thanks a lot for joining us early and getting all set up. If you don't mind letting me know where you guys are calling in from today, guys and girls, calling in from today. I'd love to share that information. Get us engaged this morning. I'm in Cleveland, as I mentioned. My name's Don Cook. I'm the CMO here at Seven Signal, and with me today is Jim Vada, our resident CWNE, and he is in Cincinnati. So if you're not familiar with the way the chat system works, there is a pane called questions in the Citrix control panel there. So feel free to share, or if you're feeling shy, that's okay too. I'll try and solicit responses from you throughout the webinar, but just thought we'd get it going. All right, I've got Parker, Colorado, and Andy from the UK. Thanks, gentlemen, for sharing. I know, Andrew, I know it's tough. I think you guys are, I think you're 7 or 8 hours ahead of us over there, so you're probably winding down the day. Thanks for making the time to join us today. And Scott, Colorado, I think you guys are 2 hours ahead, so it's still kind of early over there, though you probably had a cup of coffee or two. So thanks for joining us. The rest of you are just shy. I can appreciate that. Oh, it's only 4 o'clock in the UK. All right. Thanks, Andy. Maybe I should start calling out names, Jim. What do you think?
Yeah, start calling on people.
Keith, where are you from? Juan, Joe, Jeff,
Pass them
come on.
audio controls.
Yeah, I'll pass the presentation. I want to see what's going on your desktops right now. That's funny.
Unmute those mics.
Yeah. Keith is also from the UK. I see a Brian in here. We've got Chalky, Jeff, Joe, Jose, Juan. Come on, guys, get interactive. Let's have some fun this morning, or this afternoon for Andrew and Keith. Approaching the evening. And we're going to get started in just about, 2 minutes or so. We'll get started at 11:01 local time here. So we got a little bit of time left. Jim, you have any cycling plans for this weekend?
You know, it's the weather this time of year is usually pretty hot and muggy, so it kind of turns into the dog days for me, and so I'll go out for a few hours in the early morning and then just kind of shut it down. So all the big miles we're done in the spring.
Oh. Well, that's understandable. I can imagine what it's like riding 100 miles in the 90-degree heat and humidity, 100% humidity.
Yeah, it can be pretty miserable.
All right, Jim, I've got 11 o'clock. Why don't we go ahead and get started? All right. Well, good morning, everyone, or good afternoon, good evening to those of you dialing in from all over the planet. We appreciate you all joining us, and thanks for the responses early on, where folks are dialing in from. If you haven't done that, if you're just joining us, if you don't mind texting us in the message board and letting us know where you're dialing in from, we really appreciate hearing from all of you. Also, if you've got ideas for topics that you'd like to learn about, whether that be AX or something related to devices or the wireless LAN itself, please message us on the question board, and we'd love to add some new topics to keep the webinar series fresh and relevant. So again, thanks for joining us today. If you're here for Device Connectivity 101, you're in the right place. You're going to learn a lot of stuff today about how to keep those pesky wireless devices connected. Not from me. I'm Don Cook. I'm the Chief Marketing Officer. But you will learn from Jim Vada, our Director of Global Wi-Fi Solutions. He is a CWNE, and he'll be providing most of the content today. I've got a handful of 7-signal slides that I'm going to push through here. I know that we've got a lot of customers on the line already, so if you guys could just bear with me through four slides or so here. We do have a handful of folks that are new to 7-signal, so just a little bit about us. If you're not familiar, the company was founded in Helsinki, Finland in 2007. We relocated to the United States with our headquarters in 2012, though we do still have our Finland office, where we centralized most of our EU, North Africa, Middle East operations. Our product is certified in over 40 countries around the world. And if we're not certified in your country, we will work with your government to get our product certified there. We do monitor over 4 million wireless devices on a daily basis. That leads the industry. We've got 11 patents. So what that means is what you see from 7-signal, you'll only see from us. And our Mobileye technology, which we're going to walk through today a little bit, has a lot of great functionality that you'll only get from 7-signal. We are a software as a service organization. So that means that you'll be enjoying a lot of the not only great Wi-Fi functionality that we've gotten, that we've discovered over the last several years since 2007, but also you'll be getting free updates, free maintenance, automatic updates and upgrades, all from a simple pricing model on a subscription basis. We are GDPR ready, so we can support all of your GDPR initiatives. If you're calling in from the EU, you'll be familiar with that term. It's not globally recognized yet, but I probably see a lot of other countries going in that direction as well. So I mentioned 7-signal founded in 2007, so we still have that proven technology platform, though we have converted to full SaaS at this point. So really think of 7-signal as your one-stop enterprise-grade solution for finding and fixing wireless issues. We are device and AP agnostic, so we are really in there complementing the access points from an infrastructure perspective and really giving you some great insights on what's going on with your end user devices. So whether you are chasing after ghosts, which Jim will talk about here later today, or you have a general idea of a root cause, but you just need confirmation of what to chase after, what needs to be changed. 7-signal can provide that data to you, whether we're checking for your authentication or your MOS, giving you a MOS score, really looking at your infrastructure with our spectrum analysis. Looking at end user devices for adapter driver combinations, really looking at all of the different roaming capabilities that your devices have, or some of the interference that they're running into. All available modularly, so depending on your particular needs, we have a product for you or a service that can help. From a module platform standpoint, we really have two main offerings. Our Mobileye, which you see on the left-hand side, which we're going to talk about today. That's our app that runs on the end user device, that's easily deployed through any MDM or EMM solution, and looks at that behavior, the roaming behavior on that end user device. So it's actively testing for throughput and packet loss, latency and jitter. And and delivering a MOS score. And then there's, of course, our passive tests for SSID, BSSID, RSSI, etc. And then on the right-hand side, we've got our Sapphire Eye, which is our product that we first came to market with. This is our overlay system, our smart client Wi-Fi sensor. We're now at the model 2200, which monitors up to 6 access points. And you can see on the screen there the active tests that we run and passive tests that we run. Really strong, functional tools that we deliver to wireless engineers all over the world. And then my last slide, we've got a couple of user groups left. We just had one at Kaiser Permanente on Monday, just this week, and an excellent showing there of customer support. We've got 2 more coming up that are scheduled. One on the 17th in Nashville at Wi-Fi Trek. And then we'll be in Prague with the Wireless LAN Pros and Keith Parsons, October 7th. So if you want more information about those events, they are free to both prospects and customers. Please visit go.7signal.com/RUG, and you can register for the event that's closest to you. So with that said, thank you very much for listening to the marketing pitch. Let's get into the meat and potatoes. Jim, I'm going to hand the controls over to you.
Thanks, Don. And hi, everybody. Happy to be here. Thanks for joining us today. I'd love to see attendees from all over the world. And I know, it takes a little effort to come early in the morning or late in the afternoon or even in the evening. So really appreciate everybody that showed up. Yeah, so I am Jim Vada. I am the Director of Global Wi-Fi Solutions here at 7Signal. So that's a fancy title for a glorified sales engineer. I'm a CWNE and a CCNP wireless, and I have Wi-Fi engineering design experience in several verticals, most recently in healthcare. And you can follow me on Twitter at Jim Vada. And I have a blog, framebyframewifi.net, that's entirely Wi-Fi content, if that's all you're interested in. So that's me. Okay, cool. So let's get into the slides. Oh.
Wrong direction.
Yeah.
I can certainly talk about those again. Do you want me to advance?
Yeah, when I click, it went backwards.
That's no
there
fun.
We go. Okay, so today we're talking about roaming, and we're talking about what we can do with Mobileye to help that. And one of the big problems in enterprises is this new flood of IoT devices. And some of the problems with them, of course, they're all wireless, but they tend to be, very cheap. The manufacturers try to shave every penny off the cost of the device they can, and so they often don't roam very well. They're not. They don't have the full feature set that you would expect in an enterprise Wi-Fi client. So they often won't support some of those amendments to 802.11 that can enhance roaming performance. And so it can be a big challenge with all this stuff on the Wi-Fi network now, because it's hard to have visibility into it. Your Wi-Fi was designed well and the infrastructure is performing well, but if those clients are misbehaving, it still ends up in bad Wi-Fi performance for your end users and the systems that depend on the Wi-Fi network. So it's a big challenge. And in general, Wi-Fi roaming is a challenge. If you've been in Wi-Fi for a while, especially in the enterprise supporting mobility, I'm sure you've had the experience where you've come across clients that just simply roam very poorly, and then causes there are the IoT devices we just talked about, but also consumer grade devices coming into the enterprise. And 2 years ago, there was a much larger distinction between consumer and enterprise grade clients and computers and mobile devices. And today, those lines are much more blurred. You'll often have groups within the organization making purchasing decisions on the new wireless devices coming into the enterprise, and it's usually fairly rare for those devices to have their wireless capabilities evaluated. And it's even more rare for them to have their roaming performance evaluated. That's not really something that shows up on a spec sheet or a certification. It's something that really needs to be tested in the environment the device is going into. And the other problem is, like I mentioned earlier, there's no visibility. So you could have a perfectly designed WLAN. You did a site survey, you did a validation survey, you've got your channel plan well tuned, your transmit power tuned, you've got clients using the 5 gigahertz band more than 2.4, or even better, your 5 gigahertz only. And everything looks great, but if clients are still misbehaving and those clients are the majority of the radios in that network of radios that your Wi-Fi network is, it's still going to end up with bad performance on the Wi-Fi network because of them. And the infrastructure tools that come with your Wi-Fi network don't give you a lot of visibility, especially into roaming, which is what we're talking about. So if that's the case, your end users are still probably moaning and groaning once in a while about the Wi-Fi network being bad, even though that's probably a client issue. So let's talk about how Wi-Fi roaming should work and what the ideal mobile client would look like. So I like to think about 802.11 in terms of the OSI model. And roaming between APs is just a layer 2 transition. So as the client moves, like this phone in our graphic, he's moving from nearest to this AP in this direction, and he's getting closer to this one. This phone senses that he's closer to another AP, and his signal strength from the first AP he was associated with starts to drop. So it makes the decision to roam. And all that happens at layer 2, forms a new layer 2 association with a new BSSID, and everything above that, layers 3 and above, all the way up to the application layers, are unaffected. The roam should happen fast enough and early enough that the data rate hasn't dropped too far. There's very little packet loss, and to the end user using an application, it's invisible. So that's the ideal. And for a client that's very mobile, you want to see that happening the majority of the time as it's moving. Nice and seamless and very, very fast. It's important to note, though, that the roaming decisions, the algorithm that controls the device's decisions to roam from AP to AP is in the control of the device. It's the device making that decision to roam, not the infrastructure telling it to. So There are some limited capabilities you can use to influence device roaming, but at the end of the day, the decision-making power rests with the device. So you'll see some devices that roam much better than others, and that performance can be completely independent from the design and performance of the infrastructure itself. So bad Wi-Fi roaming, right? So this is all too common. So here's the same scenario. The phone's moving through space, getting closer and closer to other APs, but it's actually just maintaining this association with its original AP. It's sticking to it. We call that a sticky client. And as it gets further away, its signal strength drops. Packet loss starts to drop up or starts to increase. There's an increase in retransmissions, which causes layer 3 packet loss, latency, data rates start to drop, so throughput starts to suffer. And as this problem gets worse, it starts to affect all the layers above layer 2, and application performance noticeably suffers, and you end up with grumpy end users. And eventually, the device will get so far away from the original AP, sort of in the worst case scenario, that it can't maintain any association at all. It restarts its networking stack and just reconnects to the network and hopefully at that point joins a better AP with better signal strength. So we've probably all seen this. It's a pretty big problem, and unfortunately, it's something that seems to have gotten worse because of some of the issues we talked about earlier, but also because roaming is not standardized in the 802.11 standard. So the security methods that are used are all there and standardized, at least most of them that are standards-based. But the actual performance, the decision-making, the algorithms, the thresholds, none of that is defined. It's all left to device manufacturers to come up with that. And you end up with a proprietary black box without any visibility into the decision-making that's going on there. Another factor is that the Wi-Fi Alliance doesn't test the roaming performance of clients that get Wi-Fi certified. So all these new clients with Wi-Fi 6 certification doesn't really tell you anything about how well it's going to roam. Some are going to roam really well, and some are going to roam very poorly. And unfortunately, the only way to really know is to test the devices in your own environment and see how they do. So that's what a sticky client looks like. And it's still advancing me backwards when I click. That's weird. So, so what's the solution? You really need visibility. The infrastructure can tell you very little about the roaming performance of a device. The APs only see the signal strength they receive from the device, but they don't see the signal strength the device receives from your APs. And those are different numbers. The radios have different sensitivities, they're transmitting at different powers. And so you really need on-device visibility. And that's where Mobileye comes in. So Mobileye is that software agent that runs on your devices, and it collects a whole lot of data useful for a whole lot of different troubleshooting scenarios. But today we're going to talk about what it can do for you for roaming. It's vendor neutral, so we support the big 4 operating systems, and it's easy to install and deploy. You can use MDM or Microsoft SCCM or Chef or Puppet or something like that to push it out. We support all that stuff. and all the data from those devices gets uploaded to the cloud. So it makes it very, very easy to analyze. And the important data that we're going to look at for roaming performance is pretty simple stuff. AP signal strength and what are the nearby APs and their signal strength to a client. So with that, let's go into a live demo, and I'll show you what that looks like. So I will make myself presenter, and there we go. Okay, so this is Mobileye. This is the latest stable release of it. And I'll mention too, one of the great things about Mobileye is that we use an agile development model. So every month we have new features and updates, and we're able to deliver new things very quickly, which is really exciting. So it just gets better and better. But we're looking at the data from a single computer. This is James PC, and we've got a few different ways of looking at the data from this machine. Just this health checkup area up here, which is just a very quick check for the period we're looking at, which is 24 hours across these 5 areas to see how it's performed. Then we've got this new problems area, and I'll get into that a little bit more. You can see there have been some roaming problems. Then we have an assessment where we tell you over time when they've had issues and when they haven't. And then the analysis area is going to show us all the data that goes into our assessment if we just want to look at the raw data. Then our connection pane is great for just looking at what SSID were they on, where were they located. This is their physical location. And we can locate devices using the Google Maps API, which is very handy. What are the BSSIDs or AP names if we have those imported? And their channel and band. So, but just to look at roaming, for this particular machine, I'm going to look at the analysis tab. I'm going to start here first because I like to look at the data first. What we have here are all the APs this computer's roamed to in that time period, and then the minimum signal strength it was able to maintain. So you can see the signal strength has dropped pretty low a couple times. About -78 right there, that's pretty low. Then -90 dBm, that's very low. That's low enough that it's almost unusable. Any applications running on this machine at the time are really, really going to suffer. Even simple things like email that can tolerate some poor network performance are really going to suffer here. And so we flagged this as a roaming issue. See, we've got this red dot here indicating stickiness. Our assessment turned red at the same time. And why did we call it a roaming issue? Because his signal strength was -90 dBm, but we also know that from the channel scan results from this particular computer, from the perspective of this computer itself, there was another AP at -55 dBm. So a huge difference in signal strength there. And remember, roaming decisions are made by the client. And so in this case, this PC failed to roam when it should have. So this is really useful, especially if you are the administrator of a Wi-Fi network. Now you can go in and differentiate between client-side issues and infrastructure issues. Everything starts as an infrastructure help desk ticket, unfortunately. But with this tool, you can really tell, was my infrastructure performing well, or was it a client problem? And then pass it to the right team to remediate the clients. Desktop teams like this too, because network teams are always complaining, hey, you guys are deploying bad clients, the drivers are out of date, when are you going to fix this? And they don't really have a lot of visibility into it. So this is a very good and useful tool for them as well, to help untangle this problem. So we have another view for looking at this, which is new, and those are our problem events. And this is where we've taken all this analysis data and done some correlation for you, where we've flagged all of these different problems at different times for the particular client. So we'll look at roaming, and if we click on this 19, I can scroll through these 19 roaming issues that we flagged in the period, that the 24 hours that we're looking at. And we can see all the times the signal strength has dropped significantly, while you had another AP with a very good signal strength nearby. So just an easier way to look at the data rather than having to make that determination yourself. The next thing we can look at is, so we know there's a problem, and what can we do to fix it? Well, we can look at the adapter driver combination that's in use on this particular machine. So we can tell you, obviously it's a Windows Dell Latitude. We've got the MAC address and the IP address, which are searchable. So we can search by host name, MAC, or IP to find a machine. But since we're running on the device itself, we've got even more intelligence around the adapter driver combination. And in Windows, that turns out to be a really critical piece of determining the roaming performance of a computer. In this case, we've got a great enterprise wireless adapter, the Intel dual band 8260. Supports 802.11ac, it's 2x2. It's got 5 gigahertz support across all the, including all the DFS channels. Perfect. But on this machine, we've got some really old drivers. And if you have supported this adapter when it came out, you might remember how buggy the early drivers were for it. And in fact, they were the cause of a lot of sticky client issues, poor roaming issues with this adapter. So we've got drivers here that are a couple years old, and if we updated them, I'm sure James would see these roaming issues disappear. So that's cool. That's how we look at roaming for a single device. But we also have some really interesting reports that can help discover roaming issues and clients that need addressed in general in the organization. So one of them is our platforms report. And this shows us over the last 24 hours, the roaming performance of our devices divided by, or divided into platforms. So we can see we had one Android device that was sticky and a Windows device that was sticky, but overall, really good performance. Somewhat surprisingly, actually. There's usually a bit more red here. And now we've got the sunburst graph, which is a really handy way to visualize which device, make and model, and adapter and driver combinations are doing well and which are not. So in this case, if we were just to zoom in, say on the Windows platform, and in particular the Dell devices, we could see there's a Dell Latitude with an 8260 and this particular driver version that's sticky. I think we all know who it is. It's James PC. We click in, we can drill in and identify that machine for remediation. We also have some standard reports. So if I go to reports, and I'm going to look at 30 days worth of data, so we can see even more about roaming performance. We have very simply the bottom 20 clients for roaming performance. And so now we're going to see those clients that over the last 30 days had roaming issues and what was the frequency of them. So no surprise, James PC is first on our list, and we can see he had over 400 stickiness issues while he was being monitored in the last month. So, if this is a user in your enterprise, they're probably complaining about the Wi-Fi quite a bit, even though it's their computer that needs the remediation. They're still having a bad experience, and they're not totally wrong. They just blame the AP and not their own PC. So that's the issue there. And this is a great way to find those bad apples that need remediation. We talked about adapter and driver combinations too. So one of the reports that I really like is this bottom 20 adapters for roaming, because now we're looking at their performance independent of the make and model computer they're installed on, and looking at the adapters and the driver combinations themselves that are installed there. So actually, let me bring up a different organization where I think we have some more interesting data. And let me bring this up on 20 for 30 days. Yeah, so now we've got even more machines here. And if you have multiple driver versions for one machine, for one adapter, you'll see those listed here individually as their own rows. So you can compare one driver version versus another, which is really, really handy for finding that specific combination of driver and adapter that really works well in your environment. And then you can standardize on that, and you've got data to support those decisions. It's really, really a powerful tool. And so with that, I'll say there are a whole lot of other problems we can address with Mobileye, and roaming is just one. But we're really pleased with the way this has gone and the development and the direction it's gone, and look for new and really exciting features coming up here in the near term. So with that, Don, I'll hand it back to you.
All right, thanks, Jim. I appreciate it. And now we've got a little trivia question for all of you. I believe we're testing your AX knowledge today. Is that right? Is that right, Jim? Is that the question we picked for today?
That's right. Yeah.
All right. So
this
not
is the real Wi-Fi nerds that are hooked into what the IEEE has been up to.
Oh, right on. So we're going to see how nerdy you guys are today. So not related to the demo you just saw or any of the content you've seen today. This is AX related. So, and I appreciate, before I get into the trivia question, I appreciate all the questions that are coming in. I will get to those now right after this trivia question. If you do have questions, go ahead and send them through the questions pane on the GoToMeeting portal or GoToWebinar portal. And I'll address those as they come in. So I'm going to read the trivia question, and then I'm going to post it because I know some of us read slower than others. So I don't want to give anyone an advantage. So this will be for, if you answer this question right, and you're the first one to answer it right, you'll be getting a $25 Panera gift card. So good luck, everyone. Here's the question. What new feature of 802.11ax will allow for the centralized coordination of scheduled simultaneous data transmissions by providing the spectrum into resource units, by dividing the spectrum into resource units? Let me show that up on the screen. And I'm going to open up my window and see what kind of questions we're getting, or what kind of answers we're getting. All right. So very quickly, James Scott, OFDMA. You are correct, sir. $25 Panera Bread gift card coming your way. Jim, do you want to explain what OFDMA is?
Yeah, so it's really um, it's really a kind of a paradigm shift for Wi-Fi, um, at least when it is operating, where we're going from this distributed channel access model, where the decision making about who gets to access the channel, which radio in the clients or the AP is going to transmit next. That decision making is distributed, and the clients all listen first, and then if they have a pseudo-random back off, that they wait, and then if the channel is clear, then they'll go ahead and transmit. And if the receiver, probably the AP, heard the frame, their transmission, it will send an acknowledgement frame back. So it's and all of that coordination was distributed. With OFDMA, we've got a new centralized coordination where the AP itself is going to control the channel the way an air traffic controller would at the airport, and say through the use of trigger frames, divide up the spectrum and airtime for itself and other clients to transmit simultaneously sometimes. So you could have a 20 megahertz wide channel, and the AP will decide client 1 can use 5 megahertz of it, client 2 can use 10, and I'm going to use the other 5, and we're all going to transmit at the same time. And it's a very fascinating new technology that a lot of people are very excited about. So it should end up with a huge efficiency gain, and hopefully a better performance in high density areas where you have many clients all using the same channel.
All right. Well, thank you for that explanation. I'm sure I'm not the only one who needed the explanation.
Yeah, no problem.
Mike and Christopher, you guys were right. Just too slow on the draw. And catching up on some other things here, just housekeeping. Christopher from Tampa, thanks for letting us know where you're dialing in from. Ecuador and Jose, Complete Care, New Jersey, with Esteban. Thank you. Some questions that came in. Have you been able to put your mobile client on retail pricing or ordering guns? I know I've heard that
Yeah,
around the office. I didn't know if you've been involved in those calls, Jim.
yeah, we have. So we have customers running it on iOS devices like iPads and iPhones and iPods with uh, payment attachments running on those. Also Android-based devices from, off the top of my head, Zebra and Honeywell. We have customers running it on those as well.
Thank you. Thank you for the question, Mike. Question about the product being installed on SpectraLink or other VoIP phones.
Yeah. So the SpectraLink Pivot and Versity, I think I got those model names right. Those are their Android-based phones that we have customers running Mobileye on, and other VoIP phones. I mentioned Apple's iOS platforms, but also Zebra's TC51 is very popular, and MC40. We we have a lot of Mobileye installed on those as well, and those are the major ones, at least. Yeah.
All right, cool. Thanks, Jim. Thanks for the question, Mike. I answered this question for Kevin already in the chat, but just for those of you who may have had the same question, is the data being collected on the client side or the overlay? This was a client side. Mobileye is installed on the device itself. And in order to get the data that Jim was showing, obviously the agent would need to be installed on multiple devices. All that data is sent to the cloud, where we store it for 90 days. So thanks for the question, Kevin. This might be a general observation or a question from Michael. You decide, Jim. Why do APs oscillate in signal strength significantly, which causes more roaming or stickiness, especially with Apple devices?
Yeah, that's a good question. So one thing you'll find, especially with a mobile device like a phone, is just the smallest change in its physical location, or even just holding the phone, can cause 6 to sometimes even a 10 dB change in RSSI, which is a huge change. And that can be from picking up the phone and putting it next to your ear, and now your head is between the AP and the phone, or slightly shifting the position of the phone, and now the polarization is different. Or we all remember antenna gate with Apple iPhones, and if you're an RF engineer, you're kind of scratching your head, right? Because the truth is, every time you pick up a device with a radio in it, you affect the electromagnetic field around it. So it's very, very dynamic, and certainly, it actually gets there's another layer of complexity there, because you'll see individual devices from the same make and model are going to have some variance in their radio sensitivity as well. So it's definitely a hard nut to crack, and I would say a good approach to that is kind of think about the worst case scenario with your least capable, most important clients. LCMI is the term that Devin Aiken came up with, and if you Google that, you'll get some really good blog posts about it. But if you do your design around those LCMI devices and sort of take that worst case scenario into consideration, hopefully that won't be those won't cause as many problems as they otherwise would.
All right, thanks, Jim. I got this next question. I was asked in a variety of different ways, but the gist of it says, for Mobileye, if I wanted to use this at my customer sites, could I install this client on their devices and then uninstall and reclaim the license? The short answer is yes. So contact your sales point of contact here. So we do have different troubleshooting kits for scenarios just like that. So if you're a VAR or an MSP, we can certainly work with you there. We have done that with many other customers. So again, that short answer is yes. Let's see here. And I think I've got time for just one last question. This is probably a good question since we do so many things here at Seven Signal. But does the product show bad APs? And Jim, I'll pass that over to you.
Yeah, absolutely. Including, I didn't show this, but we do have a roaming report that shows the APs that clients have the most stickiness problems with. And so, if you do have a design problem, maybe there's an RF issue where as clients get near the edge of a cell, that next AP is just too quiet and they can't quite hear it until it's too late. And then there's a bit of a panic situation and a panic roam. There can be design issues that cause that. So we do have a report like we looked at earlier of the bottom 20 APs for roaming. And all the other problems that we look at as well, we can identify specific APs where those problems are accumulating as well.
All right. Thanks, Jim. And I did have another note here, Varun. Yes, I will share the slides. For those of you who do have interest in not only the slides but a recording of this webinar, we can easily share those with you. Just reach out to your point of contact here at 7 Signal if that's me, because you've received these invites from me. I'm happy to share those with you as well. Just shoot me an email or a quick note, and I'd be happy to share. So thank you for joining us today. That's going to wrap up our show for today. Each of you will be receiving a $5 Panera gift card for joining us today, in addition to our trivia winner. Was it Kevin? I'm slipping my mind. We'll be receiving the additional $25 gift card for Panera. So again, thank you very much for coming, Jim. Great job, as always. Thanks for the questions, folks, and keeping this interactive. We'll see you next week.
Thanks, everybody.